Everyone can hear me? Good. Good morning, almost good afternoon. I don't know what day it is anymore, but it's one of the days of TechEd. Thanks for coming to the session. My name is Ryan Crawcor. I'm a tech evangelist for Windows Azure, work for Microsoft. And with me today is the Robin to my Batman.
Hello guys, my name is Emil Velinov. I'm a program manager from a team in Redmond called the Customer Advisory Team, or CAT in short. And today I'm very pleased to have the opportunity to co-present with this guy.
Cool. So today we're going to take a look at virtual machines and virtual networks. And I think we're going to start off, and just to set the context, because there's such a lot to cover in virtual machines and virtual networks, this is a level 200 session, so we're going to be kind of high level. There's a lot to cover, so we're going to go quite quickly. And if I can ask that we keep the questions until the end so we don't kind of get stuck in a particular part, but happy to answer any questions you've got at the end of this. So today we're going to start off, and the session's kind of divided into two. We're going to take a look at virtual networks and virtual machines. And we're going to start off with virtual machines to kind of, and by the end of this, our hope is that you'll understand how to create, provision, manage virtual machines in Azure.
And the same thing goes for virtual networks, right? I can't remember the last time when I was working on a solution and it was just a single box with nothing to communicate with, which comes down to networking. So it is really important for us as a community and as technical professionals to understand what are the networking options available once we start looking at the cloud and when we look at hybrid deployments between cloud and on-premises resources as well.
Cool. So just to kind of, one thing when we started out with these two specific components, a lot of people looked at us and went, it's infrastructure as a service, and we're adding infrastructure as a service to Windows Azure. But Microsoft has been telling us for the last 3 years that Azure is not infrastructure as a service. It's better than that. It's platform as a service. Why are we kind of, backtracking and going into infrastructure as a service? And I'm here to kind of say that's not the case. We're not backtracking away from platform as a service. We're actually just bringing the infrastructure as a service piece on to help you bring existing stuff into the cloud. Okay? And to show you kind of a horizon of what's happening in the market and what has happened over the last couple of years, is people have started out, our competitors have started out in different places, right? So we've got Amazon and Rackspace and VMware, and they're in a particular space, and Salesforce and Google Apps, they're in a particular place. But as we've seen over time, these guys are kind of moving into the PaaS space. Okay? So everybody's converging into PaaS. Okay? Microsoft kind of skipped infrastructure as a service, and we went straight into the PaaS, and I think we've got a great solution offering there. But when you've got existing applications that you want to bring into the cloud, sometimes it's difficult to kind of do that, and that's why we've now brought on infrastructure as a service. And I believe with this, we cover end-to-end, from infrastructure as a service to platform as a service, right across to software as a service. And that's the space that Microsoft's playing in. And I believe we're the only vendor that is playing across that entire kind of end-to-end space. So when we take a look at what is available in Windows Azure, okay, we launched something called the VM role quite a way back in beta. Okay? And that was a really good way to kind of get a VM in the cloud. It had a very specific purpose. Okay? Those disks weren't persisted. And what we mean by that is when the fabric moved the VM from one kind of physical node to another physical node, or when it rebooted it or whatever, the physical changes to that machine weren't persisted. It would reboot back towards what the image was. Okay? And that's great, and it's still got its place, and you'll see that will exist in a different flavor going forward. Okay? But actually with a VM, what you really want to be able to do is you want to have a VM that persists its changes to disk. There's no point installing an Oracle DB on a VM, writing a whole bunch of stuff to the database, and then having that not being persisted. Okay. So we've now come up with virtual machines, and that's really a persisted virtual machine. Okay. And that's the big difference between VM role and virtual machine, is the persisted kind of capabilities. Okay. So today in Windows Azure, please note this is still in preview. Okay. So you can run them, you can try them out, you can use them. Okay. They are still preview though. Okay. But the images that are available today, you can create a number of different Windows servers of different flavors, base OSs with nothing on them, so just a clean kind of Windows server. You can also create Windows servers with certain workloads pre-configured and installed. Okay. And the two that we have available today is SQL 2012 and BizTalk 2010 R2 CTP. Okay. There will be other ones coming. We'll be adding things like SharePoint and those kind of things. So you'll be able to go and just create a new SharePoint server from a gallery image. We also have, much to a lot of people's surprise, a whole other family of operating systems that you can now run virtual machines on if you choose. Okay? And there's a bunch in there. And again, we'll be working with our partners to be able to provide more of those in the future. All right, so this is the key to what makes these VMs persistent, and the difference between them and VMroll is that the disks behind these things actually use Windows Azure blob storage. Okay? So the disk is actually a blob. It's in blob storage as a page blob. The VHD is there. When the VM comes up, it actually mounts to that VHD, and therefore all your writes that you're actually doing to your VM aren't being stored on a virtual disk in the VM. They're actually being stored into Azure storage. Okay? Because it's Azure storage, every change you write is actually getting replicated 3 times within the data center. And if you wish to have it enabled, it'll actually get geo-replicated to another data center somewhere else. Okay? So if your VM is sitting in Singapore, all your changes will be written 3 times to a disk in Singapore, and they will then be replicated 3 times into a Hong Kong data center. Okay? If you don't want that geo-replication, it's easy. You've got a storage account, turn it off, save yourself a couple of cents per gig, and then it'll only stay in Singapore. Okay, so when you work with VMs, and we'll show you a bit just now in the console, there's 2 kind of concepts that you can work with. Okay, you can work with an OS image, and that's what I showed you. So it's a Windows Server 2012 image, or a SQL Server 2012 image, or whatever it is. You can also create your own images. So what you can do is you can set up your VM. You can install whatever you want on it. Okay, you can set them up exactly how you want them. You can then sysprep them. Okay, shut the VM down and capture that as an image, and store that as an image. So when you want to recreate a VM from that image, it's very quick, really easy, couple of minutes, you've got a new VM up and running that looks exactly like the other one was. Okay, so you can create your own images. We've also got disks. Okay, now disk is the actual underlying disk that you can attach to a VM. Okay, so every VM has got at least one disk. Okay, it's an operating system disk, but then you can attach a number of different disks to it. Those disks are available in the console, and you will be able to see them. Okay? And you can also bring your own disk. So if you really want, you can have a VHD from on premises. You can upload it into the cloud and attach that to your VMs if you really want to do that. Okay? So currently, we've got a couple of different VM sizes that you can pick from. Okay? And they're the same kind of sizes as we've seen with the cloud services. So from extra small right up to extra large. They've got different memory, different bandwidth, and different number of disks. Okay? Each physical disk can be 1 terabyte in size, and that's because it's backed by a blob, and the biggest blob you can have is 1 terabyte. And for an extra large machine, you can attach 16 disks to it. Okay, so I can have a 16 terabyte disk attached to my extra large VM. And the way I do that is I take 16 1 terabyte files, and I create a striped volume across 16 1 terabyte files, and I've got a 16 terabyte disk. Okay. So we've got 2 different kinds of disks. The one disk is the OS disk, okay, and that every VM has. And then there's data disks that you can add. Okay, now we've got different caching policies for different kinds of disks. So for your operating system disk, the default is read-write cache. Okay? And for a data disk, the default cache is none. Okay? So the data disk is there to kind of make sure that things are persisted, in real time, so there's no lag between them. Nothing's getting buffered, that kind of stuff. If you don't want it, the policy as it is, if for whatever reason you want to change the policy, you can change the policy using that command shell, PowerShell command. Okay? And that takes us into our first demo, which Emil will run about disks.
Thank you, Ram. You're going to put that together by the time I'm finished. Virtual machine disks, that's what this demo is about. And I'll start by using a community-based project called Azure Storage Explorer that came from a company in the US called Nudisic. They created this Storage Explorer tool, which is freely available through Codeplex, so you can go to Codeplex and download it. And using that tool, what I'm currently showing you on screen is my Windows Azure blob storage account, and we can see a bunch of VHDs that I currently have in that account. So there are 2 types, as Ryan said, 2 types of VHDs. One of them are the VHDs that are directly attached as disks to the virtual machines that you are running. And then there is image VHDs, which are basically a blueprint sysprepped disk that you can create clones from. So pretty much all of these disks that you see here are actual VM disks that correspond to a machine. And then if we jump to the Azure portal, we'll see that against virtual machines disks, we have the option to manage those entities as metadata that references the actual blobs into Azure Blob Storage. You can create a new disk here. And again, this is metadata, just to point the Azure platform to the VHD file that you are storing into Azure Blob Storage. The same thing goes for images, right? So if I jump to images, we'll see that I created a single image called TechEd NZ Telemetry API service, and it is obviously an image or a clone of a server that runs some sort of web API for telemetry. And then I can go ahead and create a virtual instance. So how do you create those disks and images? So in terms of disks, they get created by default at the time when you create a new VM. So you provision a new VM, and the disk behind gets automatically provisioned. You could have the other path of uploading the disk to storage and then attaching it to the VM that you are standing up. So here I have a couple of machines. One of them is called Disk 1. And I'll use this machine. I'll remote into it to start with. I'll remote into this machine. And I will use it as the foundation of a sysprepped image that I'm going to create of that server. So I'm going into the machine. Logging in. It will take a moment. So basically, I'm walking you through the process of creating an image from a running virtual machine, and then respectively standing up a new server based off an image that we created. So here I'm into this server, which is just a standalone machine at that point in time. It doesn't have any clones or anything like that. We'll wait for the profile to load. And then what we are going to do as the next step is go into C Windows System 32 sysprep. We'll launch sysprep, and I'll show you the options that are required by the Windows Azure platform to successfully create an image of that server. It's taking a while.
Especially for a complicated desktop that's got a recycle bin on it.
There we go. OK, so let's go into C Windows. I mean, most of you would have seen this. System 32.
Who's never done sysprep on a machine before?
Prep.
Anyone? Oh, there's at least one hand. So yeah, it's new for some people. There we go.
If I could spell. So this is the directory where the sysprep utility lives in. By the way, you would run this utility after you provision stuff on that machine, your API or whatever it is. So this is sysprep running in the foreground, that little utility. You need to tick the generalize box to say that you are generalizing the machine. And then you need to pick up the shutdown option, meaning that once this utility is finished, it is going to shut down the machine, and that machine will be destroyed a little bit later on by the Azure environment in sacrifice to creating an image out of that machine. So I'll actually kill the remote connection at that point in time, because I already have my machine 2, which I sysprepped, and it's shut down. So we've been through that process already. Just to speed things up, here we go. Machine 2 is stopped. And I can just use the portal to say, capture this machine. And the image name is going to be TechEd NZ or TechEd portal, for example. I have sysprepped the machine. We'll click OK. And the image, as we can see from the status notification at the bottom, is being prepped right now. So we will end up, when this process is ready, we'll end up with an image file similar to the one that we already had for the telemetry API. And I'm just trying to switch to that. OK, so this is the image. So we have the telemetry API image created. So I can basically go create new virtual machine from gallery, my images, and here is the telemetry API, and the TechEd portal is coming up as well. Right? So that's the end-to-end process of managing disks and basically creating images and servers of those images.
Cool.
Ryan.
Thanks, Emil. Everything that Emil showed you in there in the admin console, the admin console is great. We love the management console. But some people prefer writing command line things. Okay? So there's this great tool called PowerShell. Okay? And like with everything in Azure, everything that you can do in that management portal, you can do through PowerShell. Okay? So if you want to automate the process of provisioning a VM, you can do that in PowerShell simply enough by kind of create VM PowerShell command. Right? And everything that Emil supplied, from the name to the image to the disk to everything, can be parameters in a PowerShell command. Right. So if we switch back to the deck. OK, so now we're going to take a look at a virtual machine. Okay, and whilst the virtual machine is cool, a virtual machine on its own is often kind of useless. Okay, so we take this virtual machine and we start adding it into cloud services. Okay, and what does it mean when you run this virtual machine as a cloud service? All right, so we're going to take a look at kind of the big outside kind of concept called a cloud service. All right, who's used web and worker roles in Azure before? Okay, so you guys all know that web and worker roles. You'll understand the concept of what a role is. Okay. A role is like a template, okay? And for each one of those roles, you can have multiple instances, okay? And they all live together inside of this thing called a cloud service, all right? So you've got multiple kinds of roles. You can have a web role, a worker role, okay? And for each of those roles, you can have multiple instances, okay? Now, if you remember one thing from this slide, it's that subheading, okay? That a cloud service is actually a boundary for things like management, configuration, security, networking, all of that kind of stuff. It's your black box, your ring-fenced kind of environment that we work with. Okay? And that's important to kind of understand in the context of VMs, because you'll see VMs actually sit inside of an implicit, when you create your first VM, okay, it actually sits inside an implicit cloud service. Okay? And the reason we do that is because of that subheading on the previous slide. Okay? It's the boundary for things like management, networking, security, that kind of stuff. All right? So when you start adding second VM to this thing, so you've got one VM that's in an implicit cloud service, yeah, good. You don't even actually see the fact that it's in a cloud service. Okay? When you start adding a second machine, a third machine, a fourth machine, then you actually see the fact that it creates an explicit cloud service in that you'll be able to kind of do things with that cloud service. Like I could go and delete the whole cloud service, which will kill all the VMs at the same time. Okay? I can manage the cloud service, so I can stop it, and then I'll kind of effectively manage all the machines within that container. All right, so back to Emil, who will kind of show you what I've been talking about.
OK, so this demo is about cloud services and VMs and the relationship between the two. So if you look at the screen, we are currently looking at a list of virtual machines that we have provisioned in my account. And right on top, the selected item at the moment is a machine called emilve-virtual machine 1. So that's a VM. If I switch over to services, I'm not going to see a cloud service called emilve VM1, right? Because as Ryan pointed out, it is an implicit cloud service that exists behind a single machine. However, if we go back to machines and look carefully, we'll see that there are a couple of machines that are named very similar to each other, specifically TechEd NZ Web01 and Web02. Sounds like possibly something that works together as a unit, right? And those are basically two machines that live in the same cloud service. So if I switch over to cloud services, we will see the TechEd NZ Web Cloud Service. If I jump into that, we will now, under instances, see the two machines that live within that service. Now, what is funny about the current state of the portal, there is a bug, minor bug, non-critical, nothing like this, that whenever you are in the middle of some long-running action, for example, taking an image of a VM or something like this, while you are in that state, the cloud service, the implicit cloud service behind this VM shows up as well. And we can see it right here. MLV VM1. That's a bug, right? That shouldn't be visible. Non-critical issue. The team knows about it. It's a preview release, so we are working on fixing that. And that's about it, I think.
Cool. Okay, so that was kind of VMs inside of cloud services. Now we're going to talk about virtual machine availability, okay? Because one of the things is if you put a virtual machine up there, you'd kind of like to know that it's going to be alive and it's not just going to disappear randomly, okay? So we have some service level agreements behind our stuff. The first number you will kind of recognize if you've done any work with web and worker roles, okay? And we guarantee that level of service if you have a minimum of 2 instances of a web or a worker role, okay? And the reason being is that, you know, we can move one of your web role or one of the instances around while keeping the other one alive, and we, you know, that way we guarantee that level of uptime, okay? However, for single role instances, okay, we drop the 5 and we give you 3 nines of availability. Because if something happens to the physical machine that VM lives on, the physical node or the top of rack router or something happens to that one box, okay, we need to move it or, you know, put it in a different part of the data center, there is only one instance, okay, which means you're going to lose your availability for a period of time while we perform some kind of operation on the VM, okay. But there is still 3 levels or 3 nines of availability for single instances, which we now give you, okay. So what's included? That includes a whole bunch of things. It's hardware failure, top of rack routers, disk failures, all sorts of stuff, okay? Because disks fail, especially when we're using commodity hardware, okay? Hardware upgrades, so if we're busy doing hardware upgrades, firmware upgrades to the hardware, we're busy swapping out one disk for another kind of disk, which we're doing all the time, okay? Host OS updates, that's not really that important, you know, for when you're looking at, well, everything in Azure runs on Hyper-V, right? Okay, but Hyper-V is running on a host, so at times we have to upgrade that host, okay? So that's all built within the SLA, okay? So what's not included in VMworld is the guest OS updates, okay? So with a virtual machine, it's your virtual machine, you've created it from an image, you've created whatever particular operating system you want, okay? If there's now updates to that guest OS, okay, you actually need to apply those updates, okay? And those are not included in the SLA because the actual host machine and the environment is still available. You're doing something to your guest OS, okay? With web and worker roles in the cloud services world, we take care of the guest OS updates as well because we'll spin up 2 new VMs, redeploy your app, and then shut down. So we'll take care of the guest OS updates. In a virtual machine world, the guest updates are left up to you. All right, so how does this kind of relate? So in the cloud services world of web and worker roles, you've got this concept called a fault domain, right? And we'll take your instances and we spread them out across fault domains. In the VM world, there's this concept called an availability set. So you can put your machines together in an availability set. And what we basically do with that availability set is there's your 2 availability sets. So I've got 2 web servers, 2 SQL servers, okay? And we basically will ensure that we spread those things out across physical points of failure. And our physical point of failure is usually a rack because there's a router that sits at the top. And if that router dies, the whole rack dies. Okay, we don't have a redundant router per rack. So what we'll do is we'll spread your VMs out across racks, okay? And those are across fault domains. And therefore, you'll get your update domains and your fault domains spread out like that. So should we lose this whole rack on the right-hand side, you will only temporarily lose IIS2 and SQL 2, okay? So we'll never put both your SQL, or if you use an availability set, we'll never put both your machines on the same physical rack, okay? And next slide.
Cool. So VM availability. And I'll just demo through the portal once again exactly the concept that Ran was talking about. The first one is creating an availability set and then putting machines into that availability set so that they get spread out across different physical hardware at the host level. So should one disappear of the hosts, then not all of your machines performing the same sort of workload will go down with it as well. There is someone else to carry on and continue working. So remember our last demo, we had 2 web servers that were part of the same cloud service. We are currently looking at the configuration of the first machine, Web 01. So if I go into configure, one of the settings that you can set there is the availability set. This is the second group of properties on that page. And we can see that this machine, at the moment, is part of an availability set called Web Availability. And members of that Web Availability set are Web 01 and Web 02. I can choose to go ahead and create a new availability set for my Web 01, which means that I'm disconnecting it from the association of, hold on, this machine is doing exactly the same workload as Web 02. Therefore, we should cater for high availability across physical nodes for these 2 machines. And again, the same thing. So because these 2 machines are part of the same availability set called Web Availability, if we jump to the cloud service that hosts these 2 machines, and that's TechEd Web, and go to instances, the interesting thing on that page are the last 2 columns in that table. The 2 machines are into different update domain and fault domain as well. Right? So if we decide, or if Azure is to update the host OS, for example, it is not going to reset both physical hosts that host these 2 machines because they are part of the same availability set. It will be a rolling upgrade between the hosts for those 2 VMs. Fault domain, obviously, you unplug one of the racks from the network, and only one of these 2 machines will go down. At that point in time, by the way, for that demo, we were toying with the idea of bringing a pair of scissors and a network cable and a couple of servers, and Ryan would walk in with a hooliganish look and cut through the cable for maximum impact of the demo. But unfortunately, we are talking data centers here somewhere in Singapore, so we can't do that.
But
that has been done, by the way. In the past, one of the TechEds, someone did that, and you, by the way, know that instance as well, yeah.
So I thought about doing it, but if I tried that in a Microsoft Azure data center, I may be shot. So I thought I'd not do it. Right, so kind of back to the slides. Thanks, Emil. So actually now we're handing over to Emil because it's talking about Windows Azure virtual networks.
Virtual networking, God help me. Networking is not complex enough alone, and now we talk about virtual networking as well. Why am I going backwards?
Yeah, that one.
All right, so we are going in the right direction now. Good, okay. So networking in the cloud. I want to be very explicit before we start even looking at this, that there are 2 options or 2 kind of main scenarios for networking machines together in the cloud. The first one is machines that are part of a cloud service. And the second one is machines or cloud services that are part of a virtual network, right? And these 2 options work as a stack options on top of each other. Cloud services networking is the lower end option, and then the higher end option sitting on top of that is the virtual networking, or VNets as we call them in Windows Azure. So for cloud services networking, what is interesting is that we provide for all instances that are part of the same cloud service, they can see each other, okay? And when I say they can see each other, that means that they can do DNS internally automatically. This is available out of the box as soon as the 2 machines join the same cloud service. And all the TCP/IP protocols are enabled between these two machines, pending proper configuration of the firewall individually on each server. So we have full control over the machine names at provisioning time. When you go ahead and provision a new server, you specify the NetBIOS name, effectively, of the machine. And then for DNS, I already implied that for machines that are part of the same cloud service, you have built-in automatic DNS resolution for the machine names within that cloud service. When you go beyond the cloud service and start looking at connecting individual VMs that are not connected to each other as part of a single cloud service, or when you start looking at connecting multiple cloud services together in the same virtual network, then DNS becomes slightly more complicated. Out of the box today in the platform, we don't have DNS resolution, automatic DNS resolution within the boundaries of that virtual network. So the options that you have are two for internal DNS resolution. The first one is to provision one of the VMs that is part of that VNet as a DNS server. It could be an Active Directory server or a domain controller. And then you have DNS, your own DNS. You can manage it. In fact, you can provision more than one DNS servers within that VNet for DNS redundancy and all that goodness. So that's one of the options. The second option is to connect that virtual network to your on-premises data center, which would already have an AD and DNS services enabled. And then effectively this VNet becomes an extension of your local data center into the cloud, along with all the services that you have there. So a few key points about virtual networking here. We addressed most of those already. UDP traffic is available now in VNets. Good stuff. Support for all the IP-based protocols. Port forwarding, which we are going to see a demo of shortly, so I'm not going to talk too much about it. And then the last point is an important one. We now, at the Azure load balancer level, so this is basically the load balancer that deals with external traffic into the Azure infrastructure, you can configure probes that keep an eye on your specific application. And we do that via effectively specifying a URL locally on your virtual instances that the load balancer pings every now and then and looks for the correct response from that URL, or URI, I should say. So if you have a web service, like a proper web service running on a VM, you can configure the load balancer to a specific URL that is part of that web service. It will probe it every 10 or 20 seconds. And if one of the machines that runs that web service is down and doesn't respond to that probe, it is going to be taken out of the rotation for that effectively load balanced infrastructure. Cool. So port forwarding, I promised that I'll cover that in a little bit more details. And it's a really simple concept, right? So one of the points that Ran made earlier in the presentation is that a cloud service is a hosting boundary of machines, right? And hosting boundary defines things like networking, security, and one of the important things is the externally visible IP address for everything that is hosted in that single cloud service, right? You can have multiple machines within the cloud service. You have a single IP address that is externally visible. So you are sitting outside of the service, our scenario here, and you want to remote desktop into one of those machines. You don't just remote into your cloud service. You remote into one of the machines. How do you do that with a single IP address? You basically configure endpoints or port forwarded endpoints at the Azure load balancer, whereby each VM behind that single public IP address has its own port. Okay? Simple as that. And we'll actually have a demo of this. I'm wondering whether we should be spending too much time on this, but hey, why not? So here are my two web servers. As we discussed before, Web 01 and Web 02. They are part of the same cloud service. They have the same public IP address, which I'm going to show in just a second. So I jumped into the configuration of Web 01. And in the quick glance, we can see that the public virtual IP address is this one. And that will be exactly the same configuration for Web02. It will have the same public IP address. However, if we jump back to the, actually not back, if we go into endpoints for that machine, we'll see that RDP on that machine is configured at public port 47. If we jump to Web02, public port is something else. The internal private port is what you would expect, the RDP port, between the Azure load balancer and the VMs. It's the standard protocol port. So with that, I'll just do one quick thing, which is try to connect to one of these machines. Instead of connecting, I'll save the RDP file onto the desktop. And what I'm doing right now is completely unscripted, as in not part of the demo script. So I'm just going to show you with Notepad that we are basically connecting to the specific port on that public IP address or public URI that the cloud service lives in. So that was port forwarding. The key thing to remember for port forwarding is that you can basically have individual addressing externally, right, into the machines that are part of the same cloud service infrastructure and therefore sitting behind the same IP address. So you switched that one over already?
Yep.
Thank you very much. So next one, load balanced sets. So we discussed how cloud service has a public IP address which is common across all the machines, and you may keep it that way. Web farms come in mind here. You have a bunch of VMs that do exactly the same workload, and this is to run your portal or website or whatever you are running on port 80, and you want traffic that hits the load balancer at the public IP address for your cloud service hosting the machines to just forward that traffic on the same port, for example, to any one of the backend machines. Load balanced sets, round robin, and workload kind of logic in there. And with that, load balanced sets, I'm going to show you how to do that again. Let me just find my way to the portal again. So if you remember from a minute ago, my memory doesn't go that long, so I wouldn't blame you if you don't. But if we go to Web01, there are two endpoints that Web01 has registered with the load balancer. The first one is the RDP endpoint for remoting into the machine. The second one is HTTP on port 80. If we go to the second machine that is part of that cloud service, we'll see that we only have remote desktop. So now if I externally from here start navigating to my web address, supporting that cloud service, all the traffic is going to be routed to Web01. Right? In order to start routing it or load balancing it to Web02, Web03, and so on and so forth, I need to register these additional machines. What's happening here? Something. OK. I need to register them with the load balancer as load balanced traffic going to the same endpoint that I had for my first machine, which is Web01. Right? And I'll give it a name. So Web 02. OK. That's not working well here. Web 02 web or HTTP, whatever. Port 80, it's already predefined for us. We can't change that because that's the public port defined by the endpoint that we start load balancing. And I just want port 80 in the backend network as well. So here we go. Now we are just provisioning the load balancing effectively to the two machines. We'll see when it is going to complete. Things do take a little bit of time. There is a lot of infrastructure that needs to be reconfigured in the Azure platform for certain things to happen. And as you can imagine, public traffic and routing is one of these things that is not just bang, immediate. Cool. OK, what did I do? I switched over to the next slide. Cool. So most of the demos that we have seen up to that point were applicable to VMs hosted behind a single cloud service, right? Now we start opening up and talking about cloud services and cross-premises as well. So if you have two different infrastructures of some sort, right, that need to work together and communicate together, and when I say different infrastructures, that means cloud service 1, cloud service 2, or maybe on-premises data center and my cloud VNet or data center infrastructure, if you wish. There are a bunch of different levels that you can start integrating these two environments with each other. So starting from the top, the top two are slightly reversed. I would rate probably the application level integration as a higher level on top of the data. But you have application level. This is when you start talking web services to web services, right? And you do basically HTTP calls to a URL that is publicly available or internally within the infrastructure. The second one is data synchronization if we moved it one level down. And for data synchronization, we have a bunch of different options there. So you have SQL Azure Data Sync or the Sync framework. But what is most applicable for this conversation here are the two options at the bottom, which is integrating at the pure networking level. Think VPNs, right? And this is what the new capabilities in the Azure platform implement, along with an option that we've had from the early days of the platform. So in the early days, we had a capability or a feature called Azure Connect, which was basically endpoint to endpoint, the endpoint being a single machine. So you take a machine from your local data center, you take a VM running in the cloud, and you establish a VPN tunnel or IPsec tunnel between these two machines. That's what Azure Connect used to do. And again, this is the second up option from the bottom. So with the new release of infrastructure as a service, we brought in site-to-site networking as well. And this is what we usually refer to as VNets, virtual networking, right? Good. So this is the conceptual topology and infrastructure architecture that we are looking at, right? You have the VMs running in the cloud, put together in a virtual network, and then that virtual network connects to your on-premises data center and network respectively, and just becomes an extension of that infrastructure. Or you can treat them as two separate infrastructure topologies in a main office, branch office scenario as well, right? That you just enable a tunnel between the two. Good. So connecting cloud services. Well, this is where we are stepping into the true VNet capabilities. So if you put two cloud services together, each cloud service in a VNet, each cloud service hosts a bunch of machines that are part of that cloud service. But now you are saying, hold on, all these machines, still within their cloud services boundaries, are part of the VNet. What you don't have yet, and I alluded to that earlier in the conversation, what we don't have yet is DNS capabilities, right? That's something that you need to think about. How do you ensure you have internal DNS resolution within your virtual network? And again, the solution to that is bring up a domain controller running AD and DNS. One thing that I want to be very explicit about, within the VNet capabilities, DHCP is still managed by the Azure platform. So even if you do provision a domain controller, don't provision it as a DHCP server. Leave that to the platform to manage. This is pretty much what we already discussed about extending your cloud infrastructure contained into a VNet to your on-premises resources. And the way that we establish this is by introducing a feature called the Azure VNet Gateway. So you basically, what happens with a gateway, you have your virtual network in Azure, right? And you have DNS inside, and you have machines, domain controllers, SQL servers, web servers, you name it, right? Then you have your on-premises data center. That data center is usually connected to the internet or to the public networking infrastructure through some sort of a switch, physical hardware, a router, usually. Or possibly, you may go with a slightly cheaper option where you just have TMG, Microsoft TMG, the Thread Management Gateway? Thread Management Gateway. You configure it as the publicly facing machine on your network, and it protects all traffic going into the network, and it deals with that option. Well, conceptually thinking about it, the VNet doesn't have the TMG equivalent, right, for the virtual network in the cloud. There is no TMG within your network. So we introduced a specialized capability called the gateway, the Azure VNet gateway, that performs exactly that function. So here is your cloud network. You provision a gateway as part of your network, VNet, right? And then you have your on-premises infrastructure that this gateway connects to. And it could be either your switch or TMG or whatever. Actually, there are a bunch of restrictions to what you can connect to, but we'll talk about that in a few moments. So virtual networks and VNet gateways. OK. So this is the more complicated part of the demo, where we actually have to look at
subnets and IP
configuring things. Yeah, exactly. So under networks, I can create a new virtual network. And I'll call that TechEd DemoNet. I'll leave the affinity group. Actually, no, let's put that in Singapore, which is Southeast Asia. We'll move to step 2. And now you need to define the address space. I don't know about you guys, but I'm still not used to the CIDR format or whatever it is called, the classless. What is CIDR? Classless interdomain CIDR. OK, yeah, that's the one. So OK, let's go with an address range of this. So that basically says that the last 16 bits from the whole 32-bit address value are variable for my network, to be assigned to resources in my network, right? And that basically is equivalent to defining a mask, which is 255.255 at the end, or 00 at the end, rather, right? If I went with 24 here, you are saying that only the last 8 bytes, is it bytes? Bits. The last 8 bits of your range are variable for your network. And that corresponds to a mask of 255.255.255.0, right? So this is the format that we've adopted here. You can define subnets. So I can go 10.10 10, and only the last 8 bits are variable. Actually, that should have been the name. So that's front-end servers, for example. I hope that I can paste. No. So 10.10.1.0.24. You move next. Not going into all the details. You can specify DNS servers if you know the addresses already. But right here, you can go, yeah, connect to a local network. And my gateway, that's the VPN gateway address, will be 10.0/29, for example. Connect to some sort of local network that I would have predefined, click OK, and now the virtual network is being provisioned. Later on, I'll have a quick step showing you the actual provisioning of the VNet gateway as well. Actually, no, let me just show you that right now.
I was going to say it's not. Yeah.
So I have a virtual network defined here that I've already been through that sequence. we can see that we have a virtual gateway with that blue block created and defined. And the gateway IP address that my local network, on-premises network, should be connecting to is 168.63.164.125, right? Due to some routing complications here at TechEd, we don't have the live connection, which would have been very nice to see as well, but we don't have it right now. Anyway, so once you are up to that point, you can download a script that you need to run on your router on premises in order to get it to connect to the virtual network gateway, right? So you define what your router is, you click OK, and that will give you the script for that specific model of hardware. So if I open the script with Notepad, there is a bunch of stuff that obviously a Cisco router needs. I don't pretend to know exactly what these details are. Yeah, so let's switch over to the deck. That was virtual networks and VNet gateways. Yeah.
Cool. So thanks, Emil. So we've taken a look at, briefly, at virtual machines, virtual networks, and together we can call that our infrastructure as a service summary, which I guess is what the IaaS stands for. So just as a summary for that, the IT pros, how many IT pros in the room versus developers? Ah, cool, a couple. IT pros have been feeling left out for the last couple of years because Windows Azure has been all about developers. No, not going to do that. But now, it's bringing some IT kind of pro love to Windows Azure as well, because it's you guys that kind of play with things like virtual networks and virtual machines and all of that kind of stuff. So Windows Azure infrastructure as a service is really for the IT pros, okay? It's key for us to be able to support key workloads that you guys are already doing, okay? So SharePoint Server. If you want to take your SharePoint Server and you want to run it in the cloud, it's key that we have full support for all of those. And you'll see all Microsoft's kind of server workloads will be certified over time to run in infrastructure as a service, right? So SQL Server was the first one. SharePoint's coming next. BizTalk's coming soon. So all our server infrastructure will be there. Yeah, we want to make it easy for you to manage your storage. Okay, we want to make it easy to get high availability features in there. We want to, be able to integrate with the platform as a service. So we want to be able to break, or we want to be able to build this nice ecosystem in the cloud and cross over to on-premises, cloud, whatever you want to be able to do. Okay. And I thought I'd put at the end that if it requires a developer to actually go in and write any code, then it's not infrastructure as a service. Okay. But anyway. So we've seen infrastructure as a service. Okay, we've seen platform as a service. And some people say to me, well, should I use one or should I use the other one? And my answer when I look at building workloads and when I look at architecting solutions, it's often not an either or. Okay? It's often how does my platform as a service, my web, my worker role, my service bus stuff, how does that work with my kind of key server workloads? How does that stuff work with my AD server or my DNS server? How does that stuff work together? Okay? So we want to make sure that we have a good story around that. So people say to me, well, why should I even worry about platform as a service? Why don't I just kind of run VMs all the time? Okay, well, there's a couple of key benefits for platform as a service. And if I was building a greenfields application today from the ground up, okay, I would be designing it and building it to run in platform as a service, okay, for those kinds of benefits. Okay. But like I said before, not all of our workloads today are greenfields. How many people are building greenfield apps every day from the ground up? Okay. Not many. Most of us are kind of taking existing apps that we've got and we're evolving them over time. Okay? And that's this evolution that we see kind of going forward. So we want to make sure that we can run infrastructure as a service, platform as a service, on-premises stuff, cloud stuff, all of that side by side. So over to Emil to kind of talk to you about some options around.
So the next couple of slides are really about how you can mesh up infrastructure as a service and PaaS. So cloud services, whether they are cloud services that host infrastructure as a service VMs, or whether they are cloud services that host your PaaS components, such as web services and all the likes, deployed as web roles and worker rows. One of the options is obviously to always connect these resources by the public IP address that is exposed to a given cloud service at the Azure front-end load balancer. And this is the picture that we see right now. We have a cloud service that is registered with the public Azure load balancer on port 80. And then maybe we have a database which is hosted in a cloud a VM cloud service, if you wish, and that's exposed on port 1433. The strengths of this are the fact that those are pretty much independent deployments. So from tenant point of view, there are very clear management boundaries around the two. Also, you can basically do for the platform as a service components, you can do VIP swap. So for those of you who have done deployments in the cloud, you know how you have two slots behind a PaaS cloud service. One of them is the production slot. The other one is the staging slot. So you can deploy your new version of the solution to the staging slot and then do VIP swapping for very quick deployment, consistent deployment between V1 and V2 kind of scenario. You still have that option with, if you decide to go via the public VPN. The weakness of that scenario, of course, is mostly the latency, as far as I'm concerned, because you are going out to the public cloud only to go back into the Azure infrastructure, right? And that's an obvious drawback. If you decide to put your components into a single VNet, it is more secure. You're not exposing SQL Server in this specific case as a public address. It stays within your VNet, and there are no public endpoints that go into SQL Server. This is really one of the key points here. And then the latency. You don't have the round trip to the public Azure load balancer and all that sort of stuff. It is traffic all within the network. So let me just do a quick demo. Very, very quick demo. Yeah. Switch over that. So I have a solution which consists of a SQL database running on infrastructure as a service. That's a VM. And I have a web row running a website, right, in Azure. And I put these two components in the same virtual network, right? So my web row, and this is the website that we are looking at right now, needs to get some data from the database, and I'm using data source 1010, right, which is obviously the IP address of the machine internally within the VNet. So I get some cities back. I can now switch over to the fully qualified DNS name of my SQL server, which is still, intra-network activity, and get the cities. Or I can choose the completely public TechEd New Zealand SQL cloudapp.net address for my data source. And now I meshed up, the solution with going through the public VIP infrastructure on the Azure load balancer. Cool. OK, so a quick preview of what's coming. At the moment, as it stands, a cloud service can host, in PaaS terms, two different things, well, three different things, web rows, worker rows, or stateless VMs, the VM functionality that we used to have, or still have. And the new infrastructure as a service VMs, they need to be hosted in a separate dedicated cloud service or cloud services. In the future, we'll be able to collapse these into a single cloud service, which will be consisting of web row, worker row, and if you decide to do so, an AIS row, so to speak. Yeah.
Cool.
Go on.
That pretty much wraps it up. So as a summary, I think, I hope we've given you a quick introduction to the virtual machine capabilities and some of the virtual networking capabilities. Once you start digging into them, there's a heck of a lot more detail. But we're happy to kind of address that with you, offline afterwards. So if you've got any questions, please come find Emil or myself afterwards. Otherwise, enjoy your lunch and enjoy the rest of the day. And please remember to fill in your evals. Thank you very much.
And we have